So this video is for Math 70. This is the sample final exam. So I'll go ahead and go over the problems on the sample final exam. If you have any questions on these, please let me know. I'll be happy to talk with you about them. Okay, so problem 1, we've got an expression involving x and y, which is y minus x squared over x plus y. And we've got values of x equal to negative 4.82 and y equal to 6.08. Okay, so let's go ahead and plug in our x and y values into the expression here. So let's see here, y 6.08, and then minus, and then x is negative 4.82. So that's something that people sometimes make mistakes on, is that they see the minus sign and they just put in 4.82. But there's actually two minus signs. One that is the subtraction sign that comes with the expression, and the other one is a negative sign that comes along with the value of x. And the result of that is that those two things will be added in the end. And then on the bottom, the x is negative 4.82 plus the y 6.08. Now another thing that people make mistakes on this problem with is that they try to square each of these numbers individually. The order of operations says work in the parentheses first. Okay, you've got to get what's in the parentheses down to a single number. And so we need to take 6.08, 6.08, and add 4.82, and we get 10.9, and then we can square that number. Down on the bottom, we've got negative 4.82 plus 6.08, and that's 1.26. Okay, so 10.9 squared, 118.81 over 1.26. And so we get, let's see, doesn't see, yeah, round to the nearest hundredth, so 94.29. And there we go. Okay. Problem 2, we just want to simplify the expression in problem 2, so let's take a look at that one. Okay, so we start out 5 times 4 plus x minus 3 times x plus 9 minus 7 minus 2x. Okay, notice there's no equal signs. This is not an equation. We're not trying to solve it. So what we come out with here is 20 plus 5x, and then minus 3x minus 27. That's from this multiplications right here. And then minus 7 minus 2x. All right, so now we've cleared out all these parentheses, and we've just got the adding and subtracting of the like terms to put together. So here is a 5x, here is a minus 3x, and here is a minus 2x. This is minus 5x, this is plus 5x. That makes no x's, or 0x. But most of the time we just don't write it. It's not, I was going to say it's not really wrong to write 0x, but nobody really does it. All right, so here we've got 20, and then we've got negative 27 and negative 7. That makes negative 34. So our answer here would just be negative 14. Okay. Now problem number 3 is an equation. And so we do want to solve that for x. And let's go ahead and take a look at that one. Problem 3 says negative 0.50 times 15 minus 0.35 times x plus 5 equals 0.75x. Okay, So just like we did in the problem 2, we want to get rid of these parentheses here. And so I'll go ahead and multiply, let's see here, negative 0.5 times 15. So that'll be negative 7.5 minus 0.35x, and then 0.35 times 5, so minus 1.75 equals 0.75x. So I'm going to put these two together, and I'm going to move that negative 0.35x to the other side. So let me do that first. So this will cancel out. Over here, let's see here. This is going to be 1.1x. There we go. And then over here, negative 7.5 minus 1.75, negative 9.25. Okay, so now we just need to divide on both sides by 1.1. And we get x is negative 8.409 with the 09 repeating. Okay? All right. Now we've got a couple more equations coming up here. Problem 4, we've got the equations with the fractions. So, problem 4 says 2/3 x plus 3/4 equals 3x plus 27 over 8. Alrighty. Well, like any equation, we want to collect our x's on the same side. So I'm going to subtract 2/3 on both sides. Now this 3 is the same as 9/3. So if I subtract 2/3 from that, I'll end up with 7/3. Okay. Now I want to subtract 27/8 and bring that to this side of the equation. These will cancel out, and I'll be left with 7/3 x. Over here, this 3/4 is 6/8. So 6/8 minus 27/8 is going to give us negative 21 over 8. And then to get the x by itself, you can divide on both sides by 7/3. I've learned to multiply on both sides by 3 over 7. 7 goes into the 21, and we get x is going to be negative 9 over 8. And these all cancel out over here. Okay. Let's take a look at problem 5. All right, problem 5. We've got negative 3 times x plus 2 plus 5x minus 4. And then on the other side, 7 times x minus 3 minus 8. Okay, so just like we've been doing all along, I think the first thing to do is to clear out these parentheses. So over here, negative 3x minus 6 plus 5x minus 4. And over here, 7x minus 21 minus 8. So if we collect our like terms, this will be positive 2x minus 10. And over here, 7x minus 29. So I'm going to move the 2x to this side, I'm going to move the 29 to the other side, and then we'll get the x by itself. So collect all our x's over here, and then add the 29 over there. So that'll leave us with 5x is going to equal positive 19. And so if we divide on both sides by 5, we'll get x equals 3.8. You can leave it as 19/5. You can call it 3 4/5. Those are all correct answers. All right. And then I think the last problem on this second page of the final is the literal equations. So let's see what we've got here. Problem 6 says b equals a plus xy, and we want to solve for x. Okay. So, just like an equation that has numbers in it, first we got to get the piece with the x in it by itself. So I'm going to subtract a on both sides. So now xy is b minus a. And then these are getting multiplied by each other. So I need to divide on both sides by y. So x is b minus a divided by y. And there we go. All right. Next up are the word problems. And we've got one kind of straightforward, fundamental word problem, which is problem number 7 here. And this says, translate this sentence into an algebraic equation. So, for problem 7, it says 5 times the sum of a number and 12. So the sum of a number and 12 is x plus 12. And if we want to do 5 times that sum, we need parentheses. Okay? Whenever you see the words the sum of or the difference of, if there's something getting multiplied by it, you're probably going to need to put it in parentheses. All right, so there's the first part. 5 times the sum of a number and 12 is the same as, that means equals, 4 subtracted from a number. That's x minus 4. Okay? And that's it for problem 7. Now, problem 8, we've got one of these mixture problems. Now, there's 2 types of mixture problems, and so we need to figure out which type this is. Okay? So the grocer wants to make a 60-pound mixture of walnuts and Brazil nuts to sell for $5.99 a pound. All right, so we're going to have 60 pounds of this mixture. It's going to sell for $5.99 a pound. The walnuts sell for $3.99 a pound. And what else? The Brazil nuts sell for $7.59 a pound. Okay. So, if W is the number of pounds of walnuts, and B is the number of pounds of Brazil nuts, one thing we know in this situation, W plus B has to add up to 60, right? We want a total of 60 pounds in this mixture that's going to have these 2 different kinds of nuts in it. Okay. What else? We want the value of the mixture, right, to match the value of the nuts that are going into it. So the value of the mixture is 60 pounds at $5.99 per pound. Now, the nuts that we're putting into the mixture is going to be W pounds of walnuts at $3.99 a pound. 3.99 times W pounds. And here, B pounds of Brazil nuts at $7.59 a pound. So 7.59 times B pounds of Brazil nuts. Okay. Now, this is the equation that we really want to solve, but it's got 2 variables in it. So what do? We take this equation right here, and we say that W is equal to 60 minus B, right? Subtract B on both sides, and that'll give you this equation up here. And the beauty of this is now we take this 60 minus B, and we put it in here in place of the W. So that's going to give us 399 times 60 minus B plus 759 times B equals 60 times 599. do a little bit of calculating here and simplify this equation a little bit. So we want to do 60 times 399, 239.4, minus 399b plus 759b equals 60 times 599. That's 359.4. Okay, so let's combine these b's together. 759b minus 399b is going to be 3.6b. And then we'll subtract this 239.4 on both sides. And what is this going to give us? 120. Okay? So 120 divided by 3.6, we want 33 1/3 pounds of Brazil nuts, and then that'll leave us with 26 2/3 pounds of the walnuts, and together that'll make 60 pounds, and it'll give you a 60-pound mixture that's worth $5.99 a pound. Okay. So there is problem 8. That took up most of the board, so I'm going to have to erase this to start a new problem. And so if you want to take a look at this, you can always back the video up, but I do need to make some room here. Okay, problem 9. This is the word problem where we're working to fill a tank by running 2 different spigots into it. So we've got this tank that we know is 1,900 gallons. We're running one spigot that is 15 gallons per hour. And then the other one is 55 gallons per hour. Okay. The sum of the running times of the 2 spigots is 60 hours. So let's say this one runs for A hours and this one runs for B hours. Then we know that A plus B has to add up to 60 hours. Okay. And then if this one runs for B hours at 15 gallons per hour, that means it's going to put out 15 times B gallons of water. And this one runs for A hours at 55 gallons per hour. That means it's going to produce 55 times A gallons of water. And we want those to give us, fill the tank, give us 1,900 gallons. Okay. So, again, what we want to do is substitute here. So, let's substitute in for B. B is going to be 60 minus A. And then we'll have the 55A and 1,900 gallons. Okay, so now we want to multiply here. 15 times 60 should be 900 minus 15A plus 55A is 1,900. So 55A minus 15A should be 40A. Subtract the 900 over here, and that'll give us 1,000. It looks like A is going to be 25, right? If I do this without a calculator, yeah, that should be 25, which means B is going to be 35 hours. And together, that makes 60 hours. Okay, so that's problem 9. Let's see here. Problem 10 is a graphing problem. Let's see, maybe I'll start it and then I'll put the graph up on the board here. So, problem 10. We've got this equation 4x plus 3y equals 12. And so really, a good way to do these problems is to get the y by itself, right? So I'm going to subtract 4x on both sides. So 3y is negative 4x plus 12. And then divide everything through by 3. So y is negative 4/3 x plus 4. Okay, so that's a nice slope-intercept form. You can make a table of values out of that if you'd like to, but I always prefer to graph using the slope and the intercept. So let's put the grid up on the board here. There it is. So we've got a y-intercept at the point 0, 4, right here, and a slope of negative 4/3. That means if we go up 4, we have to go back 3, and if we go down 4, we have to go over 3. And so that would make a line that looks a little something like that. And there we go. Okay, let's see, let me turn this off for a second, and we'll do problem number 11, which is another graphing problem. So let's see, I'll put that one over here. 3y equals 12x plus 9. Okay. So on this one, the y is, it's on the left-hand side by itself, but we do need to get rid of this 3, is what I'm saying. So we don't have to add or subtract anything away from it, but we do need to divide everything through by 3 to get the y by itself. And so then we come out with y equals 4x plus 3. Okay, so that's in slope-intercept form. We put the grid back up here. There we go. Let's see, this y-intercept is the point 0, 3. And then this slope is a positive 4. So we can go up 4 and over 1, down 4 and back 1, down 4 and back 1, and then we'll get a graph that looks something like that. Okay. Now, again, notice that I'm using the grid to make my graph. Okay? The x and y axis have already been drawn on this, so if there's not an x and y axis on the grid on your test, you'll need to draw the x and y axis on that grid and make sure that you're using the grid to graph your points. All right, let's look at the next problem here. Okay. Problem 12. We want to find the equation of a line in slope-intercept form that passes through these 2 points, -7, -5, and -2, +4. Okay? Well, the first thing we need to do here is find out what's the slope of the line that passes through these points. The slope formula is going to be on the formula page. So we need to do y2 minus y1. So let's say I'll go 4 minus -5. Again, notice that the formula itself has subtraction in it. This subtraction comes with the formula. This negative sign comes with the value of y. Okay? All right, so if I start with the 4, I've got to start with the -2 on the bottom, subtract from the formula, -7, this negative comes with the value of that x coordinate. So this will be 4 plus 5 on top, -2 plus 7 on the bottom. So this is 9 over 5. Okay? Let's see, what's next? Now we need to know what's the y-intercept. Well, our equation is going to be in the form y equals 9/5 x plus b. And if you wanted to call that 1.8, that's fine as well. And then we'll plug in one of these points here. Let's say I'll put in 4 for y, and then -2 for x. So 4 is going to be -3.6 plus b, and so b is going to be 7.6. So the equation we're looking for, y equals 1.8x plus 7.6. And there we go. And again, you can use fractions to represent these numbers right here. Whatever works, just so long as it's the correct number. All right, so that's problem 12. Let's take a look at 13. In 13, we want the equation of a line that is perpendicular to another line. All right, so let's take a look at this. Problem 13, we want something that is perpendicular to negative 3x plus 4y equals 8, and it's passing through, what, the point 3, 2. Okay. Well, again, first we want to know the slope. Okay, so what's the slope of this line? Let's get the x on the other side. 4y is 3x plus 8. Divide everything through by 4. Y is 3/4 x plus 2. All right, so the slope of this line is 3/4. The slope of the line perpendicular to that will be negative 4/3, the negative reciprocal. Okay, this stuff about parallel and perpendicular lines is not part of your formula sheet. The slope formula is, but the stuff about parallel and perpendicular lines is not. So if you'd like to remind yourself of how exactly that works, you can make a note to yourself on that 3x5 card and bring that with you to the final. Okay, so this is the line that we were given. This is the line that we want that's going to be perpendicular to this one and also has to pass through this point 3, 2. As a result of that, let's plug in these values. Y is 2 when x is 3. These 3's cancel out. 2 is negative 4 plus b, and so b is 6. So the answer to our question here, what's the equation for this line that's perpendicular to the one that we were given? Y equals negative 4/3 x plus 6. And there we go. Okay. Let's see here. Problem 14. This is the application problem. We're given a graph with a couple of points identified on it. Let's see, I'll do a little sketch of the graph here. Looks like this. And we've got these points 0, 1,000, and then 4, 800. And this is supposed to represent a depreciation for a computer bought in the year 2010. Okay, so 4 years later, it's worth $200 less. And so we want an equation of this line in slope-intercept form. So again, first thing we want to know, what's the slope? Okay, well let's subtract the y's on the top, 1,000 minus 800, and then subtract the x's on the bottom. If I start with the 1,000 on the top, I've got to start with the 0 on the bottom. That's going to give me 200 over negative 4, and so our slope is going to be negative 50. Now the y-intercept, we can go through this process over here for finding the y-intercept, but notice that one of these points is the y-intercept. So we can just save ourselves a little bit of trouble, a little bit of work, and say y is negative 50x plus 1,000. And then we're done with this one. Okay. Let's see, problem 15. So this is a system of equations in problem 15. Let's see, 4x plus 12y equals 7. Negative 8x minus 1 equals 6y. Well, this problem I think might work out really nicely to eliminate one of the variables, but we don't have it set up to do that. So what I'm going to do is I'm going to take this 8x, move it over here, and then I'm going to rewrite the whole thing. I'm going to say 4x plus 12y equals 7, and then 8x plus 6y equals -1. And there we go. Okay, so now to eliminate one of these variables, we can do either one. We can eliminate the x's, we can eliminate the y's. Either one would be pretty straightforward. Let's see. I'll multiply the bottom one by -2. How about that? Okay, so the top equation won't change. 4x plus 12y equals 7. On the bottom, we get -16x minus 12y equals +2. And now when we add these equations together, the y's cancel each other out. We get -12x equals 9. Divide on both sides by -12, and x is -3/4. Okay, well then we'll come back over here and plug that in for x, and then find out what y is. So these 4's cancel, so we'll have -3 plus 12y is 7. Add the 3 over here. 12y is 10. And when we divide on both sides by 12, y will come out to be +5/6. So there's our answers. X is -3/4, x is positive, y is +5/6. All right. Let's see what we've got next here. Problem 16. We've got the rules of exponents. So again, the rules of exponents will be on your formula sheet, and I encourage you to refer to them while you're working on these problems. Let's see. -3x squared y to the 4th, and then that's getting multiplied by 2xy cubed to the 3rd power. All right? So, the order of operation says we should do this exponent first. Okay? Inside the parentheses themselves, there's nothing really that we need to simplify. So this one will just stay the way that it is. This one, everything will get raised to the 3rd power. Okay, so we'll come out of that with 8x to the 3rd and y to the 9th. And now we can multiply, put these two together. -24 x to the 5th, y to the 13th power. All right, let's see. Problem 17 is similar. Let's see. -2b to the 3rd c over bc to the 4th. And we want to raise that to the 2nd power. Now you can raise it to the 2nd power right away. I would recommend simplifying inside the parentheses first, right? This b will cancel out one of those b's and leave us with b squared. This c cancels out one of these and leaves us with c to the 3rd. So what we've got now is -2b squared on top, c to the 3rd on the bottom. We want to square that. So that'll be +4b to the 4th on top, and c to the 6th on the bottom. All right. Let's see what we've got for problem 18. Okay, so now we're into the polynomial problems. Problem number 18 is 3x minus 2 squared. Okay. Now, one thing I want to mention is that in this problem, notice that we just raised everything that was in the parentheses to this power. Same thing here. Now, one thing I want to point out, notice there are no plus or minus signs in here. Okay? That's why we can just raise everything to that power. Once you've got plus or minus signs in there, you can't do that anymore. You've actually got to square or cube or whatever power that is. You've got to multiply this thing out that many times. Okay? Because here we're going to get 9x squared, and then minus 6x, and then minus 6x, and then plus 4. So 9x squared minus 12x plus 4, and there we go. All right, I think number 19 is another multiplication problem, a little bit longer. X plus 3 times x squared minus 2x plus 9. Okay, so if we want to distribute this, each of these terms into the other set of parentheses, we'll get x to the third minus 2x squared plus 9x. And then if we distribute here, plus 3x squared minus 6x plus 27. And so we come out with x to the third plus 1x squared plus 3x plus 27. And there we go. Okay, so those are the multiplying ones. I think problem 20 is just the one where we have to add or subtract. Let's see here. Yeah, problem 20 is the subtraction of these two polynomials. So this one, negative 4x to the third plus 2x squared minus 5x minus 7. And then we want to subtract 4x to the third minus 3x squared minus 5x plus 8. All right. So, again, notice this is multiplication right here. There's no sign in between there, right? Same thing here. These are getting multiplied. These are being subtracted. Don't try to distribute and multiply these. This is subtraction. So all we have to do is take our parentheses off and then combine like terms. Now, we do have to distribute this minus sign into the parentheses, but it's not, nothing from here is getting multiplied by anything over here. So minus 4x to the third plus 3x squared plus 5x and minus 8. All right, so let's see here. We've got some x cubes. That'll make negative 8x to the third. We've got some x squareds. That'll make positive 5x squared. Let's see, we've got some x's, although it looks like those are going to cancel each other out. Positive 5x and negative 5x make 0. And then in the end, we've got negative 7 and negative 8. That makes negative 15. And there we go. All right. The last two problems are factoring problems. The first one is a trinomial factoring problem. Where are we? 21. X squared minus 3x minus 28. So what this says is that we want factors of 28 that have a difference of 3. There aren't that many choices here. You can have 1 times 28, 2 times 14, or 4 times 7. And notice that the 7 and the 4 have a difference of 3. So, put our 7 and 4 in there. We want a negative 3. That means the 7 should be negative and the 4 should be positive. Okay, let's see here. 22. We're going to look for a greatest common factor. Let's see what we've got here. 8 x squared y cubed plus 16 x to the third y to the fourth minus 20 x cubed y cubed, and then 12 x squared y to the fifth. Okay. So we want to find the common factors for 3 different things. The coefficients, the x's, and the y's. So I'll do each one separately. In the coefficients, the 8 and the 16 work out nicely. They both have a common factor of 8, but these ones don't. So if we bring it down a step, maybe these all have a common factor of 4, though. And after we factor out the 4, we'll see if there's anything left there that might be another common factor. But we'll start with the 4. In the x's, we've got a common factor of x squared. And in the y's, our common factor there is y to the 3rd. So what's left here? This will be 2. We factored out all the x's and all the y's, so that's just going to be 2. Then we'll have 4. We've got x to the 1st left over and y to the 1st left over. Minus 5, let's see, x to the 1st only. And then plus 3y squared. And notice that inside here we don't have any more common factors, so we know that we factored out the greatest common factor. Okay, so that's what's going to be on the final. If you have any questions, please let me know. Thanks.